Hello everyone, this is Dr. E, and today we're going to be working on how I teach my students analytic geometry or the conic sections so that they'll be able to understand the many formulas involving our circle, ellipse, hyperbola, and parabola. Hello everyone, so yes, learning the conic sections and or analytic geometry can be extremely challenging for our students, and for today I'm going to share with you how I help my students to get rid of their math anxiety when it comes to learning the many formulas of our conic sections. And this is what we're going to be talking about in this week's or today's lesson idea with Dr. E. So conic sections, for students who are watching this video, we have several videos on conic sections that you can watch and learn. It's on the description box down below. So check it out, check our playlist, check our practice exercises, because conic sections, it's all about getting yourself more familiar with the formula, how we use it, and how the formula changes depending on the shape of the conic sections you are working on. And for teachers, you can use my videos for your students, and Numberbender videos in our YouTube channels are all yours, which could help you and your students in learning and hopefully teaching conic sections or analytic geometry. So the first tip, or the first thing that I teach my students who are learning conic sections for the first time, usually in my intermediate algebra or in my pre-calculus class, completing the squares. So it's all about linking their prior knowledge or something that they are more familiar with, and that is the completing the square technique, which is extremely important when we are converting or when we are finding the equation of the conic section given the parts of the conic sections. So this particular algebra skill is important, and I highly suggest that before we move on to conversion of our conic sections formula, our students are well aware and have mastered how to complete the squares, like finding the perfect square trinomial. Why do we have quadratic equations that looks like quantity x plus 10 squared or quantity x minus 25 squared in some of our conic sections, and why is it always appearing in our analytic geometry or conic sections problems? So yes, completing the square, that's one algebra technique that you can practice or you can refresh your students with, because it's extremely important that they know their algebra fundamentals to be able to understand parabola, ellipse, hyperbola, and circle. And yes, these are the four basic conic sections that we have, and we also need to let our students understand that there are actually 8 formula. Yes, that's a little bit too much, but that is the reality. We have 8 formulas. That's why most students are really confused or having trouble understanding conic sections, because of the fact that they need to know all these formula by heart. And for our students to have less problem or less confusing conic section formula, I always tell them that there are always 2 sets of formula in a conic section. One that is opening upward, one that is opening downward, or something that has a shape that is a long ellipse or a wide ellipse. And when they realize that it's all about the shapes and associate the shape of their conic section to the formula that they are using, it becomes a little bit more manageable. So I have here 2 circles, and just like any conic section problem, so we have 2 types of formula. So for a parabola, it depends on how it opens. Does it open upward or downwards? In ellipse, what is the shape of your ellipse? Is the ellipse a tall ellipse or a wide ellipse? So that's basically just my description on my ellipses. So I'm not sure how you describe your ellipses, but that's how I describe mine. And then for the hyperbola, it's the same. How does it open? To the left or to the right? And for this particular problem, I just want to show you why Sometimes it's easy to work with conic section when the center or the vertex is at 0, 0. And it becomes a little bit more challenging when the center or the vertex, when it comes to parabola, is at hk, or it moves around the xy plane. So just for example, we have here the basic circle that looks like a weird circle. So forgive me for my drawing right here, but we know that the center of our circle here is at the point of origin, which is at 0, 0. So if we plug it into the formula, which is basically identical, even though the center is of different position, this is how they would connect, that it's all about just this formula and knowing how to derive the formula depending on the center or the vertex when it comes to parabola in a conic section. So here, since the center is at 0, 0, hk is at 0, 0. So y minus 0 squared is equal to r squared will be the general form of this particular circle with center at 0, 0, which we can simplify into x squared plus y squared equal to r squared, which is basically the radius squared. And in this case, it's 2 squared. And we're going to fill it out later on. But I'm just showing you why sometimes conic sections can be as easy as this, or are easy to work with, just like the circle with the center 0, 0, and why it becomes a little bit complicated when the center moves away from the point of origin. So here, h and k would be, h would be associated with the x-axis, and k would be associated with the y-axis. So in this case, the center is at 0, 1, 2, so positive 2 for h, and for k, which is for the y-axis, 1, 2, it's also a 2, so we have 2, 2 for hk. So our equation will become x minus 2 squared plus y minus 2 squared is equal to r squared. And this is when you will show them the importance of using the graphing paper when you are learning the conic section. So I always use a graphing paper. I have a big supply of graphing paper whenever I have lesson on conic sections, because I find it easier for my students to teach them conic sections when they are drawing it or sketching their conic sections using the graphing paper. And you will see it in my examples on the video down below. So this is how the degree of difficulty changes from easy to not so easy when it comes to the conic section. And it's true for the other 3 conic sections: parabola, hyperbola, and ellipse, which of course my students are well aware of, because this is basically how I show or share them the beauty of conic sections, and how I teach them why sometimes we need to be analytical when we are solving problems similar to what we have with analytical, see the word there, analytical geometry. So 2 skills: completing the square for algebra, and you need an index card or a cheat sheet to start with for all the formulas that you will have in a conic sections for parabola, hyperbola, ellipse, and circle. And there are many transformations depending on how it opens or how your conic section looks like. And for teachers who are watching our video right now, how do you teach your students the conic sections? And if you have your own technique and strategy, comment down below, and I would love to hear from you and see how I'm going to be able to apply it in my own classroom, just like how you do it in yours. So again, this is Dr. Esperanza, and in conic sections, it can be confusing, it can be a little bit intimidating, but if you know your strategy and how you will prepare on how to be able to conquer conic sections, it will be a lot more manageable. May not be easy, but manageable. So get your index cards, make sure to write the formula correctly, and make sure that you have mastered your completing the square technique, so that when you work with problems in conic sections, you will be prepared on dealing with all of these. So this is Dr. E, and see you again next time.